Hi, welcome back to our fourth week of our class on the theology of artificial intelligence. This week, we're going to be looking at the issues of algorithmic bias, and we're also going to be exploring some of the potential applications of artificial intelligence within the church. This is our last week together, and I'm really glad that you've stuck around. So why don't we just get started?
Last week, we discussed the ethical questions that attend to artificial intelligence. In particular, we looked at problems that arise when we put artificial intelligence in the driver's seat, asking software and the programmers to make decisions between life and death. The problem with programming machines to make ethical choices, we learned, is that we do not share the same intuition ourselves, and we lack any common ethical framework. Still, it's incumbent on us, as the range of applications for artificial intelligence and machine learning grows in daily lives, that we prevent machines from committing unethical behavior. Ideally, we want to go beyond that goal. What we'd really like is for machines to become human companions, improving society by helping us to overcome our limitations and shortcomings. In our final week together, we'll consider how to improve artificial intelligence's ability to make decisions. We'll also look at ways in the present and the near term that we are soon or will soon be living with artificial intelligences in our churches. I hope this week that you will take away a renewed impression of the danger and the potential of AI for our religious lives. We will be living with these strange creatures, these aliens, from now on. How can we bring them into conformity with our social norms while also benefiting from their unique capacities and abilities? Let's begin with a quotation from the computer scientist Pedro Domingos. In a recent interview, Domingos said the following about artificial intelligence. People worry that computers will get too smart and take over the world. But the real problem is that they're too stupid, and they've already taken over the world. What counts as smart and what is stupid? How can we live with machines that can handily beat Garry Kasparov, or Magnus Carlsen for that matter, in chess, and yet cannot interpret the punchline of a knock-knock joke? We're used to living with people with various levels of cognitive ability, and we sometimes make fun of professors who, for instance, can solve equations in quantum physics but get lost driving home from the grocery store. But we're definitely not accustomed to living with beings with such extremes of capacity and incapacity. And yet we are already coexisting with these artificial intelligences. As we listen to this video, for example, AIs may be churning out subtitles in the background, trying to interpret what I'm saying to you. Software does a pretty good job at rendering my spoken words on screen, but so far it does a terrible job of interpreting the meaning of my communication. There's a channel on YouTube called Translator Fails that pokes fun at how Google Translate renders popular songs after converting them between languages. Machine learning can help us find patterns in the world, but it lacks the capacity to identify the meaning of patterns and to ask normative questions about them, and that's where matters can go very wrong indeed. If machine learning algorithms are good at spotting patterns, that leaves open the ethical valence of that pattern. There are lots of patterns in society that exist empirically, but we wish normatively would disappear. For instance, we can find patterns of racial discrimination in employment, schooling, housing, and other areas of social life. As machines spot these problem patterns, we'd like them to counteract them, not amplify them. But by the very nature of the algorithms themselves, the tendency is exactly the opposite. Machine learning algorithms tend to elevate patterns when they identify them, meaning that computerized models wind up perpetuating the worst aspects of human behavior. They look at what we've collectively swept under the rug, bringing what we have hidden away into full light. I mentioned last time that a number of scholars are working on exposing computational bias and providing ideas about how to remedy it. Here you can see a selection of a few key recent works in the field. Cathy O'Neill's Weapons of Math Destruction was among the first publications to expose the shortcomings of computational models. O'Neill noted with alarm that while software is increasingly making important decisions, from whether we get approved for loans, to whether we make it through the hiring process to get a job, or whether prisoners are released on bail, these models remain opaque and in many cases proprietary. If we have the opportunity to inspect them, we frequently find that they use problematic proxies for data they lack. For instance, using credit scores to estimate our trustworthiness as employees, magnifying pre-existing social disparities. Safia Noble's Algorithms of Oppression focuses on the algorithms behind search engines and other recommendation systems, showing how they learn from unsavory patterns of human behavior to magnify prejudice, leading to harm among minority communities who find themselves represented and distorted in injurious ways online. In 2019, Aaron Roth and Michael Kearns, two researchers at the University of Pennsylvania, published a monograph that proposes ways to counteract bias in algorithms. While they note that we can require machine learning algorithms to satisfy conditions of fairness, introducing such constraints also decreases the accuracy of those models. Achieving an optimal balance between fairness and accuracy remains elusive, a task akin to squaring the circle. Still, we can and should become better at programming machines to reduce bias when making predictions, especially when it comes to the more vulnerable among us. A common proposal is to make algorithms more transparent, that is, to make them interpretable to the general public. That way, if a software system recommends against giving me a loan, I can understand how it reached that decision. I might not agree with the decision, of course, but I'd have insight into the process. This sounds reasonable, but it turns out to be difficult to implement in practice. After all, if I showed you the source code for some software, you wouldn't be able to make heads or tails of it unless you had experience programming in that particular language. And even software engineers might find it challenging to understand the algorithms implemented in the code. Machine learning algorithms add an additional layer of complexity. The nature of deep learning algorithms, which develop so-called neural nets composed of thousands and potentially hundreds of thousands of interim linkages, produces models that resist any interpretation. We may be amazed at the way they handle traffic on busy freeways or produce realistic deepfakes of celebrities, but following the route by which the software achieves those results is beyond human ability. Does this mean that we should give up on interpretability? Not at all. We can make models more transparent in other ways, for example, by sharing publicly the data that goes into the model and then evaluating how well the system forecasts the result. Of course, problems also arise here. Not everyone wants to share their financial data publicly, and not everyone wants to admit that they were turned down for a loan by the bank. Given the parallel concerns to maintain privacy and confidentiality, making the workings of models transparent proves a difficult task. Another proposal for remedying bias in algorithms is to increase diversity. In 2017, Apple released their iPhone X. A new feature of the device was the ability to unlock the phone with facial recognition. This feature only works if your face alone can unlock the device. Shortly after the release, a number of surprised buyers in China discovered that friends and families could unlock their phones with their faces as well. Newsweek reported that a woman from Nanjing discovered that a coworker could unlock her device, leading to speculation that the phone was, quote, racist because it could not tell Asians apart. The use of computer vision has prompted several episodes of this kind, where misclassifications of people produces social harm. How can we fix the situation? Well, we can start by making sure that we train computer vision models with diverse data sets. If software engineers develop models simply by training them on how their friends appear, it should come as no surprise that those models fail to label strangers properly. This provides another example about how the lack of diversity and implicit bias in contemporary society becomes reified and magnified in machine learning systems. We might parenthetically ask if Presbyterian churches would do any better than software engineers at creating diverse inputs for computer vision algorithms if they train them on their own congregations. A ready solution would be to train computer vision models on a diverse array of faces. In January 2019, IBM released a diversity in faces dataset that incorporates 1 million images of people to provide better results for computer vision research. These faces included people of different genders, ages, races, and ethnic backgrounds. By selecting input from a broader array of human beings, we can avoid the worst kind of misclassification errors. What about requiring software developers and the firms that employ them to implement safeguards against algorithmic bias and other forms of AI-related harms? In 2019, Senators Cory Booker and Ron Wyden and Representative Yvette Clarke introduced the Algorithmic Accountability Act. The goal of the bill was to mandate, quote, companies to study and fix flawed computer algorithms that result in inaccurate, unfair, biased, or discriminatory decisions impacting Americans, unquote. In his press release, Senator Booker explained, quote, this bill requires companies to regularly evaluate their tools for accuracy, fairness, bias, and discrimination. It's a key step towards ensuring more accountability from the entities using software to make decisions that can change lives." End quote. The bill would have charged the Federal Trade Commission with developing these regulations, but the draft failed to make it out of the Committee on Commerce, Science, and Transportation. Given public concern over the role that software systems of large internet companies play in American society, we will likely see future legislative efforts. As with any legislation or regulation, the trick is averting or remedying the harms while preserving the capacity of firms to innovate. The notion of granting an administrative agency oversight over potentially harmful algorithms and machine learning models actually goes back a few years. In 2016, Andrew Tutt, then an attorney at the Department of Justice, presented a paper at Yale's Unlocking the Black Box conference about creating a new agency with administrative oversight over certain classes of algorithms. In a subsequent paper titled An FDA for Algorithms, Tutt argued that the new agency should be formed on the model of the Food and Drug Administration, adopting a standard akin to that agency's safe and effective standard for approving new drugs. As he noted, the FDA did not come into existence until a series of deadly incidents, including the poisoning of more than 100 people, mainly children, by a medical compounder in Tennessee in 1937, forced the issue of medical safety onto the public stage. He asked whether we need to wait for similar disasters in the world of AI before establishing an oversight agency. Tutt writes, quote, "Those who favor free markets may think a federal regulatory agency is too radical and more than is necessary at this early stage. However, given the pace of algorithmic progress, it may not be so early. The unique dangers algorithms pose, coupled with their complexity, make them similar to technologies we have closely regulated in the past. It may be that the future is here, and the time to treat algorithms as a mature technology, deserving of society's watchful eye, is now." End quotation. Among the many thorny issues to figure out, however, would be the classes of algorithms that come under the purview of such an agency. As I mentioned in a previous lecture, software systems are composed of many parts, algorithms to be sure, but also databases, source code, third-party binaries, internet application interfaces, and so on and so on and so on. How many of these tools would come under the scrutiny of this to-be-developed agency? How long would the approval process take? Another possibility is to require developers to discuss their algorithms with institutional review boards before undertaking their machine learning projects. If you're not familiar with the concept of an institutional review board, or IRBs as they are called colloquially, they exist to provide feedback and guidance about the use of human subjects in scientific inquiry. IRBs came into existence in the 1970s as a consequence of a series of scientific scandals in which researchers carried out experiments on people without informing them of the dangers. The most infamous of these studies was the Tuskegee study that ran from 1932 to 1972, in which researchers did not treat the syphilis afflicting some African American participants in their study in order to follow the progression of the disease. Clinical trials now that affect human subjects must go through IRBs to avoid repeating these kinds of unethical incidents. Should IRBs also examine the influence of algorithms on human subjects? No one likes being made a test subject without their knowledge, and yet Facebook did exactly that in 2012 when it altered the news feeds of selected users without their knowledge to study the effects of so-called emotional contagions. And A/B testing, that is, showing different versions of websites to random groups of people in order to see which is most appealing, is standard practice in the advertising world. Making sure that people who may be adversely impacted by software have a seat at the table when deciding on its uses seems like a good idea. Thinking back to our self-driving car scenarios from last week, for instance, we might like pedestrians to be in the room when designing algorithms to handle unavoidable crashes, rather than only drivers. But this suggestion also suffers from ambiguity. The boundaries of clinical trials are much easier to define than the potential application of algorithms. What might be benign in one context might be malignant in another. Public opinion about what is right also changes over time. When Google first introduced Gmail in 2004, there was significant pushback about its perceived lack of privacy safeguards. Today, few people worry about the privacy implications of Gmail, though perhaps more should. So sentiment changes over time as people grow accustomed or alienated from certain types of software applications. Crowdsourcing takes a similar approach to setting up institutional review boards. The leading idea here is to allow people to, quote, speak back to algorithms and to correct harms caused by AI. For instance, the Partnership on AI has implemented a procedure for reporting injuries caused by algorithms. The Partnership on AI describes itself as, quote, a multi-stakeholder organization that brings together academics, researchers, civil society organizations, companies building and utilizing AI technology, and other groups working to better understand AI's impacts, unquote. Among other projects, the partnership launched a web-based forum to report incidents of AI-caused injuries. What kind of examples does the Partnership on AI have in mind? Quote, a few examples. An autonomous car kills a pedestrian. A trading algorithm causes a market flash crash, where billions of dollars transfer between parties. A chatbot advises a mentally ill person to self-harm, in quotation. To date, the site claims to have collected more than 1,000 incidents, which researchers can request for study. This type of feedback mechanism is extremely useful, not only for obvious injuries, but also for aggregating information about negative outcomes from machine learning processes. If we harken back to our previous example from Kathy O'Neill about algorithms turning down loan requests without adequate explanation, a feedback system like this one would allow those adversely impacted to find a collective voice and advocate for change together. The next step, beyond crowdsourcing responses to algorithmic injuries, would be organizing to counteract those harms in advance. Joy Buolamwini, a self-described poet of code, founded the Algorithmic Justice League while a graduate student at the Media Lab at MIT. Buolamwini organizes workshops on identifying and overcoming bias in algorithms. Among other initiatives, the Algorithmic Justice League developed a Safe Face pledge in 2018 to challenge companies not to use computer vision algorithms for military purposes, and also to commit to monitoring their software regularly for incidents of bias. If you're interested in her work, she delivered a wonderful TEDx talk titled, How I'm Fighting Bias in Algorithms. Could churches become centers for resisting the negative impacts of algorithms, machine learning, and artificial intelligence? Certainly the notion of reducing algorithmic injustice resonates with our commitment to justice in general. Quote, the people of the land have practiced extortion and committed robbery, said Ezekiel. They have oppressed the poor and needy and have extorted from the alien without redress. Might we provide redress to those who suffer from algorithmic bias? If we are to take on that role, we as church members need to become more invested in understanding the technologies at play. Now that you've taken this course, you're very well on your way toward that goal. As we come to the conclusion of this series, I'd like to highlight some positive aspects of artificial intelligence for the church. Algorithmic bias is a serious concern, but algorithms and artificial intelligence also bring happiness and joy to people's lives. In these final few slides, my hope is to highlight how algorithms can foster the mission of the church in fresh and unexpected ways. Caring for the sick includes a growing number of people afflicted with forms of dementia. The loneliness of people suffering from such diseases of the brain is palpable. Social isolation has been shown to accelerate the progression of the disease. Taking care of a pet is a time-honored remedy for loneliness, but these illnesses frequently rob the afflicted of the executive function required to handle animals' daily needs. A solution is to provide an android substitute. The animal appears lifelike to the patient, who can dote over it and enjoy its company, while not needing to take it out for walks. Scientists are evaluating the potential of using these android animals for therapeutic purposes. Problems persist, however, as robots also have needs. Batteries run out of charge, and sometimes computerized brains must be rebooted. A reporter commenting on the phenomenon of android pets noted how uncanny it was when a robot dog rebooted, apparently dying, and then returning to life minutes later. In Japan, nursing homes have gone a step further by introducing robot animals, but also android therapists who patiently lead residents in physical activities. The results appear positive, though the use of these robots raises questions for human caregivers. As Lane Shannon Valor, a professor at Santa Clara University, asks, quote, "It's what happens to us. What happens to our moral character and our virtues in a world where we increasingly have more and more opportunities to transfer our responsibility for caring for others to robots," end quote. I'm not sure whether this next example fits our narrative very well, but I'm going to throw it in for fun. Last summer, my family and I traveled to the Netherlands for a business trip. At the end of our stay, we visited Dordrecht. Some of you may know that the Reformed churches, that is the family of churches that include the Presbyterian denomination, held an international meeting or synod in Dordrecht in 1619 called the Synod of Dort. We wanted to tour the special exhibition at the Hof van Holland Museum. After we concluded our visit, we came across this robotic scribe in the courtyard. The robotic hand was meticulously writing out the entire Staten Bible, thus like the King James Bible in the Netherlands, by hand in the courtyard of the museum. Titled Bios, Bible, the installation was an initiative of a German art collective called Robot Lab. The purpose of the exhibition was to transpose the medieval scholastic labor of copying a biblical manuscript into the modern age. The robotic arm never tired, writing perfect letters without cease. Anyone who has examined a medieval manuscript knows that the scribes were not so perfect, and that they even doodled in the margin from time to time. But this robot did not get distracted or bored. The final copy of the Bible looked uncanny in its exquisite perfection. Let's return now to East Asia. I'd like to share two potential harbingers on religious applications of artificial intelligence to come. The first is a short story that Professor Helen Shen brought to my attention. The story is about a futuristic Korea in which robots do all the manual labor. In this story, titled Ready-Made Bodhisattva, one of the worker robots listens to the Dharma talks while carrying out his cleaning duties in a Buddhist temple. He subsequently becomes enlightened and begins sharing the Dharma with humans, who listen with rapt attention. The story raises the intriguing question, can artificial intelligences become enlightened and help others too as well? In case you might dismiss this story as pure science fiction, let me now share another example from Japan. The Kodachi Temple in Kyoto has installed an android called Mindar to share the Dharma with temple goers. Mindar, who resembles a traditional bodhisattva named Canon, reads and interprets sacred texts for humans. Here is a quotation from an article about that robotic Buddha. Quote, "If an image of Buddha speaks, teachings of Buddhism will probably be easier to understand," said Tensho Goto, the chief steward of the temple. We want many people to come to see the robot to think about the essence of Buddhism. Unquote. If the Dharma is delivered via robot, does it remain the Dharma? If the gospel is preached to us by an artificial intelligence, does it remain the gospel? To round off this series of classes, let me end with a brand new machine learning tool from OpenAI called Jukebox. Jukebox creates new musical compositions based on a massive data set of more than 1 million songs. The ability to generate new music from the data itself is amazing. A similar service called AIVA created the soundtrack that you hear during the intros and outros of my video. But Jukebox goes a step beyond, taking lyrics that you provide and generating music and vocals in the style of any musician or band that you choose. Would you like to hear what Old 100 sounds like when sung by the Beatles? Or the doxology as interpreted by the Eagles? Now you can. The idea of machine learning being used to praise God in new ways, making a new sound to the Lord, sounds like a fitting place to wrap up our series. Thank you for joining me for this whirlwind tour of artificial intelligence and its potential for the church. Thanks again to Guy Griffith for the invitation to deliver this series. I hope someday to talk with you about these ideas in person. In the meantime, take care and be well.